Okay, this is not going to be an easy one to walk you through, but we're going to go through it, and then we'll stack it from there. All right, request-wise, please watch the commercials for me. That way it gives me some algorithm boost, I think. So I know they're not fun. Also comment, it is kind of funny how, how the commercials are kind of odd. Everyone tells me things like, hey, look, I really do use a deodorant, but they keep pushing this deodorant at me, like that person that said that. I thought that was funny. Or another one said they're pushing booze on me. I'd like to see the booze commercial. Look at this video down here I have called Champlain Towers Collapse, Pool Deck Concrete Core Samples Failed. Deck very obvious in core samples. All right, here are your samples. This is B5. As we go to 8, and Tom, I wanted to give a shout out to you on something here. Let me jump right into the repairs to hit on. So let's look at this deck repair. This says pool slab full depth repair. So that deck had some major issues with it. I talked about that in the video, and I don't know if that video or another one. But this shows it was failing in the middle. Now, I think what happened was, using all the witness statement now, specifically the Nayers, the 111 people, that I think that when she heard collapse, when she heard the floor fall down above or wall fall down, and the daughter said the same thing, I think what happened was part of the deck in the garage had an initial drop, and then a stop. And that stage stop went all the way over to the building and shook their building. Now she goes to at that point she doesn't look out the window. She doesn't look out the door, right? She goes to the office. She walks down the hall to complain about noise. And then she hears a loud bang from the garage. I think that's the secondary, the final equilibrium, becoming equilibrium at that point. It breaks free totally and collapses down, and it does a secondary breaks all the way back to the building again. And I'll get you to the building there, to the beam. Let me do that biasly now. So 24. I should go to page 11. Well, before I do that, I want to show you these are full deck repairs. I want to show you something else that's kind of a ridiculous statement on here. Let me back up. Not on my part. I make a lot of those, but not right now. So that's a slab drop right there. See, topping slab pavers at storefront at slab drop right there. And slab drop again. And your BMAs, of course we know them, they're beam style A, right? But BMAs are the quick way to get to it. Just say BMA, just do the abbreviation. You don't have to say beam A, just BMA. For the triggered people out there, you'll get over it. All right, so I'm on page 15 now. I want you to think about punk shear protection, about critical shear zones. Well, this is a BMA right here. This is the beam A. This is the BMA right here. And look what they're doing here at a BMA. This says gravity epoxy full thick crack. A full thick crack. You know what that means? That means this concrete has pulled away in the rebar engagement, as we talk about it in a very light manner. We have some pull-out going on here. To get pull-out, we have to have deflection. We have to have loss of stiffity. Stiffity to get pull-out. You got loss of stiffity. Yes, I said stiffity. All right, so this will be the deck. And so here's our non-breaking part on this side of this BMA. So let's do that. And on this side, so here's our beam, here's our concrete. Right in here is that crack, so I'll give you a little piece of concrete right there. All right, we can push that up. So, thanks Bruce. So there's the crack. How do we get that apart from each other? Well, what happened was they decided to stretch, like, oh, is stretched apart, right? Oh, okay, so this stretches apart. What happens? This beam, this BMA has to push somewhere. It has to go with it, right? So bear with me being facetious, guys. I hope you understand I'm being facetious now. Oh, wait a minute. That cuts a shear across the top of this BMA. Oh, so they got to move together. Oh, yeah. Oh, wait a minute. Not for free. There's a wall here. Not for free. So, oh, whoops, it runs into the wall and knocks the wall over. It doesn't present that way. But what it presents as this. Let's go back to that crack. Let's move this out of the way. So here we have, let's look at it in the capacity. This is amazing, the title of this one called, this is a non-structural crack over here titled over here. This says partial thickness non-structural crack. It looks friggin' huge. To get that, you would do the same thing to get this one. To get this full crack, you're looking at a hinged deck. You're looking at deflection in a deck like this. This deck deflected. I'm exaggerating to get you there, but this gets you there. This is really. I want to grab this little guy. This gets you there. This is my exaggeration crack. All right, that's opening. That's going to be higher, thicker here, tighter here because this is compressive down here. It's going to want to hit that, but that's the exaggeration version of it. All right, so this is at what? A critical shear area, isn't it? Because it's right above. This is connected at a column, and that one's connected at a column. They just ran a deck and then put this like upside down strong back in there. This is connected at a column. And this crack represents deflection and the deck. The deck over on this side. Oh, wait a minute. We got a crack over here. That crack represents deflection in the deck over here, like this. And when it falls down, this stays here, thereupon connected to the column here, and we get this opening. There's a compressive moment in here, but it took it to the point where it didn't fracture all the way through, and it went that far. Now, there's a load between the two. This is carrying a load. This BMA rather, it's going across, right? Remember the BMAs look like something like this, right? So there's a BMA. This one here would be this one. Well, if we could look at it sideways like this, and let's put a column going down. Let's do that. And there's a column over here also. We would look at it at the end of it. We would see this fracture. And this fracture is somewhere in there representing that this deflection, that this is deflecting. Again, creating the tension in the steel, tension in the concrete, and it's reacting right there, showing a full crack. He's showing both sides. Both sides. That's fully developed all the way through with this type of detail here. I don't know how long it is, but it's showing it. Look, here's a secondary one down here where it wants to come apart. Now this is going to add up. It's going to add up real fast for you if I get to page 13. If this is the right 13 document. So there it is again. This is around your right around this. This one's kind of shallow near the top, but nevertheless, it's still it's an cantilever past there. It's again by your BMAs. Your BMAs, right? It's by your BMAs. So your BMAs. Now, here's a problem I'm having. It actually says it's by. We go to page 11. Here is our KLM. Here's M, K, L, and M. Right about here, we're going to see on the next reveal. Yeah, you got to bear with it, guys. It's good. It's really good data here. It's really good stuff. We just went over this in that previous video. But lo and behold, we're right here by the stamped concrete. Where's the stamped concrete? Now he's doing his own test. He's doing his own. He's working by himself. He did this, and over here is like a Bosch laser. I know I've got. I think I have the similar laser. One of them, also. So that's why he probably has the board up so he can spot the dot. and do his elevations, however he's figured out his elevations. But this appears to be by that planter. There's your ballard. This is right in front of, planter, by the driveway, and he just blocked it off. Okay, so welcome back to D4, etc. These are the samples. This shows you this deck. You know, all these people talking about they running programs and let's just bash on him. Josh said I ran a calculations and it wouldn't. Look, we're looking at it right now. Right now. So stop with the calculations bullshit, smoke and mirrors, trash, lie talk. You didn't run any calculations on this. No one has. Can run calculation on this. You look at this and you call it broken. When you start testing samples, as soon as it fractures, whether it comes off the top a little bit or cracks all the way down, the sample is done. So now I want to bring you to the ASTM 239. These are what fractures look like. They're labeled types 2 through 6. And you can see that even a partial fracture is considered a failure. And you can see the different types of fractures, how they present. The one to the top left is like a cone. It's balanced. It's beautiful. The one to the top left, it's a real consistent fracture. The one to the middle had like shear fracture going left and right down the middle, so it's split down the middle. These are the fractures that present under compression load testing. We see lateral failure in our samples, a flexural capacity cause those teeth to grind, if you will, or break apart. In fact, using the rebar as part of that plane shear. Fail. This has failed in multiple times. 1, 2, 3. This presents as steel right here. So there's a layer of steel there. That would put it at what? That's 1 inch. That's 9 inches. About 8 inches apart. And so it puts it high and low again, as we know. About 1. Hey, girl. About 1 inch apart. And then we have, this is D1, D2, D3, D4. The way he broke it up. He had to number them. She or he had to number them so to remember how they came out of the damn hole. You normally can number one sample. This one came out, went through the steel there, and look at this thing. Well, he did take a piece of steel out. That's interesting, right? That is interesting. Remember, I got to get it fractured through M, and I'll get us through M. You'll see. But look at this thing. It's multiple layers. It's like each one's a sheet of paper, one piece of plywood. Imagine if you took the layers apart and you stepped on it, they would just bypass each other. 1, 2, 3, 4, and that might even be 5. So that's what I'm showing you there, is that these are, everybody, all these engineers saying they did calculations on the deck are just full of shit. They're full of shit. They did no calculations on this deck. None. This is what the deck presents as. This is the deck. It presents as a failed piece of material decking done. Now, I'm just trying to think if you rolled it over. No, that looks like it's a separate. I'm looking at the scale. Yeah, this is another piece. This is another piece. They're both about 13 inches. I don't see this, even if you rolled it, I don't see this piece being over here or there. This piece is too long. This is a 4-inch piece. I see no 4-inch pieces down here. So these are two samples. Both samples came showing back this deck has got all types of fractures and lateral movement from, say, here to here. And maybe this is the cover, the pool deck area with the, maybe drill right through the pool deck, I don't know. But this one is pretty damn trashed also. I mean, it's just trashed. There's that one piece of steel there. Now, core sample A. Mr. A comes right down by column M. Mr. A is column M, right in front of the planter box, which is right in front of there. This is our shit deck. This is just one of the exploratory holes, not a core sample spot. What they call a test probe area is just a box that they cut out, removing the materials, and then they just sort of jackhammer at it, with a chisel, however they get to it. The core sample is the drilled sample right next to it. So over by the parking garage area, we have a core sample and also a test probe area. As I understand it, they asked for a couple of extra test probe areas. I don't know if it was core, maybe it was both. Nevertheless, for extra money. Nevertheless, you can see that this is the test probe area right here about M, and next to it, 1/3 in approximately, is the core sample, which is all fractured. So this is what I'm trying to get cleared. So that's too far back. Well, let's come here. Here's the parking garage. The parking garage where we have the shear plane failure, right about here, shows that deck was shit. There's a dissection of it before the collapse. We're looking at it. It's shit. There is no calculation that Josh can run. There's no calculation that any of those other engineers you guys send me links to can run. If they run it, you're being lied to. Again, using the concrete guidelines, ASTM C39, you see that what the fractures typically look like under compression. These fractures are not, they were under a dead load of deflection. And that deflection with the steel created that bypass effect, multiple layers of it. Further, they were under cycle loading from the vehicles running back and forth, back and forth. This had a lot of cycle loading one way or another. And we need to find rusted rebar to determine it was water related also. It's broken up. There is no calculation for this. Anybody who does testing will tell you that this is a failed sample. Whatever it came out at is whatever it came out as. Incidentally, there's a report attached to this about these. I can't find a report. Tom and I tried to play around with it. I called Tom up and we talked and said, Tom, can you find a report? He couldn't find it either. We couldn't find a report on what they finally said about this. And maybe we're looking at it right now. Maybe this is the extent of it. But you're looking at right here, RM. Test probe. Approximate section line. 1'6" elevation. What we got going on here? So they took a piece of steel out. Note it. We got it through M, baby. I got us to M. I got us to M. I have us on these BMHs. BMAs are in a failed capacity that that they need. Some of them are failing, fractured. They need full support. So let's get you that full support thing. Why? So right here is where the repairs are supposed to be. All of them coming out to this S2C-2.3. The repairs. They basically tear off the deck and go from there. Have you all of this junk? Everything there. All of it is off. Just OFF, right? Punk shearing, right? Oh yeah. So here's this deck failing where it comes up to that BMA. So it comes up to that BMA. So this is what I think is the fractured one. This one, or it could be this long one here, or this long one here, or this one. Now, I'm going to show you support of two of these parallel to each other. So it's either supporting this one and repairing this one, I think was going on. So support this one and this one. Why they repair this one? It's an odd duck on repairs. And that would look like, we go back to our repairs. There's a lot of punk shearing issues going on. A lot of, right here, going up to a BMA. So that's going up to a BMA. You support the floor before it. And then you take out this section, not cut out, you break it apart, jackhammer it, whatever, you follow the notes. You put the more reinforcement at the top, you close it up. That helps get this deck tied into this BMA, transferring the loads down the columns. One of these BMAs has the fracture all the way through though. It's already, so page 15, right here. This BMA, this one that's loaded, I'm going to be impartial and I'm going to be quite biased. Okay, I'll just tell you straight up. I'm going to be quite biased and say that's probably our M. So as this deck collapsed, it probably hit that weak ass one right here, because you remember this is tied in. I want to do this release differently, but this is multiple decks. See, this goes up to here, and then this is another deck up here, 12'9", and there's reinforcement inside there, so it's not solid filled concrete, at least not per the drawings. It's another mini deck that goes up, and then you have a 7-inch step into the property. So it's a deck over to this BMA, beam A for you sensitive folks, and then this BMA as it stays there, and then it goes up an additional 1 foot 11 inches, and I think that would have been changed to probably 1 foot because of the elevation change by 1 foot here. So they would deduct 1 foot from here. So again, we lose our BMA sizing to help support this decking, but it's pretty close there. But nevertheless, it's the end. It's where the deck connects there. It connects here. It then goes to the porch here, which is at 12'9". All the way over to here is 12'9". This is another deck, 7 foot out, but at the same elevation. You can see the rebar, why I call it another deck, because the reinforcement is hook shaped. It stops. It doesn't cross over. They wanted it to come to the BMA. I think we have the deck initially getting some puncture down and over a slight bit, maybe even over to there. So it would be all this area. Delete. Let's do it again. So let's do this and let's turn. Let's go towards the pool. Let's turn and let's go at the expansion joint. Look, isn't that amazing where the dots are lining up with the expansion joint? Isn't that friggin' amazing? So here's another triangulation point, and then in the next one I talk about what section lines are. I grab a screenshot, show you guys what section lines are. I think it's noteworthy inside this shot that came out of the report. It calls this a test probe area, but yet in that test probe area they also gave a statement of how thick it is, but yet that test probe area was only probing a surface area, if you will. And I believe up to the left of that box is where the actual core sample was taken. So it's kind of iffy on this one. So I think that they had initial bump was this dropping down, so a slight drop. Maybe 2 inches. Let's call it 2 inches, right? Nothing for free. Nothing for free. That's 2 inches. It tugged on the structure, and it caused the shaking above them, and it made one of the walls, the internal walls, the block walls, possibly fall over, and that's when she went to the lobby to complain. This did not fall down all the way through yet. It was able to find equilibrium grabbing again, and held on for a moment. While she's making the complaint, this accelerated creep, real accelerated, this part, bloom, dropped down over to, I'm not going to go that far yet, to there. He does his observation, Joe Friendly, whatever his name is, the son, does his observation from the porch, as he states. He then goes to the door. The mom starts running back after that. She runs back, not through this way, but apparently through the hallway. She runs back. We got to leave. They meet her at the door, apparently, or thereabouts. And they go to the exit. Mom says the story about how she had to get them to leave. I heard a couple say you don't like her smiling. She's a kid, you know. She didn't get the gravity of it.
Before the tower fell.
And that's a pun on words because you guys know I believe in equilibrium.
Along with her daughter, Hani, one of the 2 children who were there. Thank you both so much for being with us. Sarah, I want people to understand.
I call it inappropriate laughter. It's not, I don't think she's laughing. She doesn't get the gravity of it. You know, many people died, and she's smiling, happy to be on news. Or she does, and she's a baby narcissist. You know, we'll find out.
How close this really was. It was late, you know, or early in the morning, 12:30, 12:40 in the morning. You were doing emails, and then you heard a sound. What happened?
Exactly. I just came from a party, like spiritual party was, and it was 12:30, and it was a little bit noisy. My son and my daughter being around me, so I didn't pay attention to the surrounding. It was so
So we know at 12:30 nothing collapsed, right? She came in the building.
12:45, she went to take a shower.
So 15 minutes later, still good.
And my son was
12:45.
busy, so suddenly it was quiet. I was sitting and
Remember, suddenly it was quiet around 12:45. Quiet.
checking my emails and my messages, and then I start to hear knocking sounds, knock, knock, knock here and knock, knock. And I said, okay, somebody probably hanging pictures on the wall. And then it was more intense. And I said, oh, probably they're doing some small renovation. And then suddenly around 1:10, I hear like a smash, the wall is collapsing, the wall above me.
So this is the part that, see, the knock knock part I can get is even a washing machine above her having the tumble, the clothes in the wrong side. Nothing will bang on that side of the drum pretty hard. Bang, 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 bang. That would give you a knocking sound. But she states that a wall, like a wall falls down. So that's why I have to add this other step right here where I'm stating that possibly that we had a primary, the initial break, which tugged back over to M, and she's over here, tugs on M, and causes one of the walls to flex a little bit. That gives that lady time to get out. Remember 611? So 611, because if I don't do that, and we now know what we know based on timeline, I would only have the lady upstairs having 4 minutes to exit, and she puts out candles and things like that. Remember, she also says she was able to put approximately 2 fingers in the wall gap. The way she points it is kind of weird, off to the side, so I'm really confused. And also saying she's using candles, so does that mean she had the lighting on? Was this candle light? So, she leaves because of that vibration up there. So I think that what she heard, the banging, that vibration is possibly already taken place at this point, up to the wall. And then she goes out to the lobby to complain to the guy. She says guy multiple times. So she doesn't recognize the security guard, the lady security guard, as a lady. She thinks it's a guy.
I said, wow, they're really doing major construction. I need to take care of this problem. It was already 1:10 in the morning, so it doesn't make sense. So I ran to the security guy that I live in the ground floor. So
not guard, she is saying guy. You'll hear it in a bit. It's guy.
It's first floor. So it's really a wall separated between my apartment to the security guy. And I ran to him and I said, do you
went to him and I said,
hear this sound? It doesn't make sense in the middle of the night, early morning, people doing construction. So he said, yeah, I hear this.
He said, yes.
It's also noises. So I said, so what do you do about that? The minute I said, what do you do about, then it was a big boom.
So that's the big boom. She's in the lobby at this point. She's going to walk down the lobby and see the cars crashed.
And I was running to see where the sound come from, and I saw all the garage collapse.
So remember, the security guard said it was the elevator, but clearly she was participating also, and she had no problem going beyond the elevators and looking into the lobby area out this window here, and noticed the cars collapsed. She says all the cars collapsed, right?
I couldn't believe it. I thought I'm in a movie. I look again and I ran back to the hallway and I saw my two kids.
And I ran back to the hallway and I saw my two kids. See, they were at the hallway at that point. But remember, he tells a story that he's the hero, but we'll move on. We'll just accept her story. And we, quite frankly, we don't really need his story anymore. He's adjusted his story since the Twitter one. But we don't need it. It's nice, but her story is more solid because I don't like how I know that you guys can we know about stress and everything else, but at one point you now made yourself the hero in that. How come you didn't make yourself as my mom? You didn't remember your mom sing in the hallway and come out? She's not disputing it.
I look again and I ran back to the hallway. And I saw my two kids standing next to the door.
I saw the two kids standing next to the door. Remember? And he tells the story. I told him we got to get out of here. And really? So apparently his amygdala won't allow him to play second fiddle to this incident.
The entrance of my apartment and don't move.
And they don't move, right? See, they were shocked. That's what I remember. That's how I reported it before I realized it was him. They're shocked. They're in shock, you know.
Standing in the next to the door, the entrance of my apartment, and don't move. And I was screaming, "It's an earthquake! An earthquake!" I was thinking very fast. I said, "It's not construction. It's an earthquake." And while I was running, I told the security guy, "Call the police, put the alarm, so people will, be aware about this."
Yes.
So when my daughter was looking at me, I said, "But I'm with my bathrobe." I said, "I don't care. Run as fast as much as you can." She was running with her brother towards the exit of the building. And the security guy, he was shocked. He didn't know what to do. I said, "Call the police." And he said, "But what is the address of this building?"
He didn't even know.
He didn't know. He was
He didn't
so
know.
confused. And I said, 877. Said, "No, write for me." And I told my son, "Fast, write for him." And he wrote. And we ran out of the building. And I told my kids, "Run as fast as you can, crossing the street." We crossed Collins. We just crossed Collins. God watched us. God was waiting for us to leave.
Okay, so yeah, when it collapsed, it didn't just cross Cloudlands. It's a little bit different. She's compressing time at that point. But now we see that I wanted to tie it together for you now. I think we have, because we need her to go to the lobby, right, to have a reason why she's here to all fall. Plus, we need 611 to, plenty of people get up to start making phone calls. If we just use her account only, it's at the tail end of the collapse, where we still need the model chick to make a phone call, and we still need other people to get up, blow out candles, get dressed, grab their circuit breakers, turn off their lights, and leave the property and walk down some stairs. So we just can't have that happening right then. Besides that, their floor is still in place. So remember, the timeline of the floor is 118. At 122, it goes down. So at 118, she films the floor. The floor already collapsed. Took a second to get her camera going, figure out where it was perhaps, and filmed. When she filmed the whole building and she realized that her eyes could probably see that something's the water inside, she zoomed in on the water, not knowing that she's zooming in on the floor falling. It fell at a 111. I believe that 111 our collapse now. We have structural integrity problems that we can lead clearly from these samples. Clearly from these samples we can get there from here. So let me move this out of the way. So we've got these BMAs. We have the sample. We have the deteriorated materials. These BMAs are these BMA type are all shit. Now let me get you the supports right here. So this is the supports of those sisters, those two BMAs. Now I can try to extrapolate, but the scaffolding was just done could be stretched in software and things like that. These two little ladies are side by side. This is a single. This is where repair was going to go, and that's also critical share area that we're talking about there. So there's plenty of failures that were already identified for this deck to collapse. Plenty of failures. IMO, in my opinion, pretty obvious. So what I want to show you this, going back to this. So we have two of them together, those supports. Are they this one and this one, and then they're going to fix this BMA here, and also it would have to be supported while they're fixing it. So is this it? And then support the deck that leads up to it. So we're looking at the three of them together. Well, they present as the same height, but the architect, engineer rather, leaves location. He's not specific on this location, just not specific, but we only know of these type BMAs over there. All right, so now we have multiple decks. Remember this again. This is the pool deck and the garage deck are the same level. All right, so that's the same level. This is not of the same level. This steps up to 12'9", which would still step up to 12'9", but you would lose a 1 foot step. That puts us in this, again, multiple decks here and here. This is where our other flower, this is important because this is where we have the flower pots that present as level. So that shows you that's a separate deck area that when it went down, here's our shear plane. right? And this is what every materials came and collapsed in here. But here's our shear plane created, and that went down together on its own little separate deck, elevated at 12.9, elevated at, so 1 foot greater than this deck. Now over here again, we have the samples. This shows defective. This is, I mean, it took me a long time to get you guys here, but hopefully you'll understand. So don't follow any of those engineers that tell you that they ran calculations. What's, I mean, couple of you are in the medical field. If I bring you a broken bone, a fractured leg, how much weight can I lift on that fractured leg? Just tell me, how much can you calculate I can lift? You would tell me, well, nothing until it heals. You should be limping on it. So I wouldn't give you any load ability. I would say you're going to limp, and possibly die of gangrene if you don't get it fixed. And you're going to set it, and it's going to take 6 weeks to heal, 6 weeks, and then we'll go back and revisit the muscle atrophy that you have. This marriage is broken up. It's been shearing, running across each other for a long time. Now, it looks like it might have been a piece of steel. Okay, so I want you to look at the edge of this book. Pretend like it's a concrete pad. My right hand, I'm going to, let's see if I can do this right. As I drop this right side, trying to keep the bottom kind of flat. Look what happens here. Out of plane, stresses take place. Stresses take place to pull this apart. This would be our crack at the where we see the small crack that they call non-structural. That would be because the right side of the deck, or somewhere past that point, has now started sagging. It starts sagging or being pulled, or pulled would be a full fracture. But if I have a full crack, if it's wide at the top and narrow at the bottom, well, that means it not only did that, but it then shifted just a little bit, which means it's slid down the rebar. So this would be our rebar. So when it shifts, the rebar is supposed to stop it. But look at the rebar. Look at the reaction of the rebar. It's moving, isn't it? If one is still there, or it's not. One is going to grab the rebar, and one side isn't. It's probably more than likely not going to be an equal holding force. Closer to the L shape is probably going to be a stronger section, and so this would be the section that the rebar would slide out of and create that opening. So that would be a rebar. Now, so the shear planes I'm talking about, look at how deflecting it. I have a bunch of shear planes in here. Now you take that into maybe 4 shear planes per the sheet, and now you can see that we're getting deflection in multiple ways. Oh yeah, so that's I bought a bunch of these Costco shirts because the Children's Hospital, they were selling them, and then the money went to the Children's Hospital. Problem is, I can't go anywhere. I go somewhere, oh, you work at Costco? I go there all the time. I'm like, read the shirt, it says Children's Hospital. All right, so it's a donation. So look, and so there's your shear planes right here. So that's stable, and that's not. Remember, I give you data because I know where I'm going to go to it. When I talked about the book thing, I knew I was ultimately coming back to it. I won't say it. I won't say the symbol and then come back to you. I won't say it. I didn't say it. All right, it's pretty hot here. All right, take care, guys. Love you all. But it's been rubbing against each other, moving up and down. This location right here is right here by the car garage. It's been cycling its ass off, as I talked to you about cycling. It's been cycling disgustingly so. There is what it looks. There's a core sample, how beautiful it is internally. I love to see the. So C up here. That is by. Oh, that's up there. So that's interesting. Where's the core sample? Oh, there's a core sample there. Oh shit. Yes. The whole deck is just shit. This is coming into the driveway area there. Look at that. Look at that one. Okay, let's see how they present, how they fail and similarities. So we got a 2-inch break, and then we have, let's call it 8.5, and then 10.5. 2, 8.5, and then 10.5. So then let's look at this one. Nope. Let's zoom back out. Really, I'm waiting for it to catch up. 2, 8.5, and 10.5. Really? I'm waiting for it to catch up. I really need to step my game up on this computer programming stuff, don't I? So this one is here. That one's there. Nowhere near it. Oh, that's a pun on words, isn't it? So that one's dissected itself. What did I talk to you guys about? What did I tell you about steel? You show me the steel, I'll show you a control joint. I tell you that steel acts as a control joint. I've stated this numerous times, pissed off a lot of engineers on it. The steel is not just a reinforcement, but it's also a control joint where a fracture, thereupon a fracture is created. There's the steel, there's the fracture. There's the steel, there's the fracture. This one's right above that steel there. All right, there's the steel, there's the fracture. Love cracks. All right, so test probe A. Okay, so again, very interesting that they took out, okay, there's 11 inches. Remember I said about it's 1 foot 11, and then we take off the 1 inch elevation, and there's your 11 inches, because the deck came up 1 foot. So there it is. Core A, right about there. And we got all these fracture materials. I think this is very profound for you to just enjoy it. This is the deck right in front of it. So M is right about, what the hell is this? Right about its plywood. Is that the waterproofing for the underneath the tile for the whatever it is? But that's one ugly hole. I mean, I'm thinking they're getting below the bedding material, but that bedding material looks like that's about it right there. So what is this crap? You know, what is this? What is this? I saw it. I saw it over here too. It's the stamped concrete on top right here. Pretty damn thick. With wire mesh reinforcement, no waterproofing, 10 1/4 inch thick structural slab. Okay, 10 1/4 inch thick structural slab. How can you call that 10 1/4 inch structural? How can you even call that structural slab? You would just say, you know, 10 and. I find this, guys. Look, would you walk across something like that? Let me ask you that. Would you walk? So I got to be fair. So I use you as the public. Would you walk, if you could see this all broken up like this, would you walk across that? And it was a drop below. Would you walk across it? Now, would you drive your car across that had you seen that? Now, why is this being used, this thing being used as a parking area if it looks like this? Why? Why wasn't it load restricted? I don't get why it wasn't load restricted. I think there's some money to be made there. You know what I'm trying to hint at? You guys, you finish off the rest of my words because, you know, I can't be caught on that in the wrong word with the wrong wording. But you figure out what I mean. And this deck here, you know, the car restrictions. I mean, that's our breakaway. Now I'm going to show you in future videos how these interact together. I'm going to get 1, 2, 3, 4 layers. Okay. Yes, I'm going to be bad. You need a trigger warning. I'm offering you 13 inches today. 13 inches. This is the one-off, one day only, because I don't really have that. But I'm offering you 13 inches. Why am I doing it in such a capacity? Stating such because it will help you remember. But I'm offering you 13 inches in sections. I'm only going to give you 4 inches. Then I'm going to give you the balance of that, which would come to a total of 7 inches, let's call it. Just about 2.5 more inches, I think it is. And then I'm going to get to the point. You just hold on there. Then I'm going to give you 2.5 inches. Looks like I'm kind of screwing you, aren't I? You're never going to get at least, you're not going to get at least 6 or 7 inches out of this deal. Wait a minute, the last piece I'm going to give you is about 3.5 inches. So it seems like I scammed you, I bedazzled you. I told you I had 13-inch deck. Oh yeah, I did say that. I told you I got a 13-inch deck. But in reality, I'm kind of broken up, aren't I? I'm kind of not really there. I'm really not giving you 13 inches. I'm giving you pieces of deck. This helps you remember it. I want you to realize that. You will not, hopefully, was it Amy got to go get a cigarette? Hopefully this makes you smoke a pack on this one to remember that I may be offering you 13 inches. I'm not really giving you 13 inches, you know? A girl said to me once, this is Red Fox jokes, give me 12 inches and make it hurt. So I did it to her twice and hit her over the head with a brick. Well, this is the same thing that they're doing here. They're giving you 13 inches, but in multiple stages, really? And then remember, a rebar is in here, and it can't really work because it's already fractured. It's just, it's nothing. It's just I don't mean it this time. I just want to show you how they can really slide. It really is not engaging this piece. This piece and this piece are not engaging because it can slide through. Yeah, I really don't mean anything sexual this time. But the point is that the steel can bypass. All right, it can bypass these sections as we see the grinding of the teeth, etc. So hopefully this 13 inches, you'll realize when somebody offers you 13 inches, hey, are you offering me really 3.5, 2.5, 4.5, and then 4 again? I think I can do better somewhere else. So they may be offering us a 13-inch deck. You know what I mean? Wink. Look, who I remind you of? I'm the Miami police chief. So anyway, I'm offering you 13 inches. Remember he says, good. We're going to really investigate this. What a friggin' joke. Listen, Hillsheimer, what do they need him for? If he's not allowed on the website, if he's not allowed on the site, and he can't figure this thing out the way we figured it out. When I say we, I'm saying you guys give me a lot of support with the comments, etc. Keep me motivated to go at it. Otherwise, I would have just not continued. But if you look at my video way back in the day, I've already said it's here. It's got 35,000 views. I already commented that it was here. But it seems like you guys didn't pay attention. So I had to take it a long way back around to where we are and with a little more modeling, perhaps. So if anybody's interested in my 13 inches, remember I'm conning you. I don't really have 13 inches, nor would I want it. All right, so hopefully this is entertaining, and you won't forget the importance of when somebody offers you, are you really offering me the full package, or are you giving me pieces? But it's already an issue. This is fractured way over to here. All fractured up right at the what? Critical shear area, right? It's right about there. There's a critical shear area transforming over here and here. This is where it transfers over to the critical shear area right here. That rebar is right about upon the critical shear area. The 16.5s coming there, and then going down there the 10.4s, which is awesome because we know it's 10.4s, and this says it's 12.4s. These are 1/2-inch steel, and this is 5/8 inch steel. We would be, if we can use a tape measure on this, we would be able to see which steel it is. Oops, wrong one. We would be able to see which steel, what steel it is, and we'll be able to tell you which section it is. That looks, I'm going to guess that's the 5/8 steel. Not that far. It's too far out. It's too far out. That's damn near 1/3 out. Yep. Dot. I'd say it's about 1/3. So with this one, let's do the 1/3 here. Okay. Just before the dot. 2, 3. 1/3. So that's 1/3. So 1/3, it puts it out of the critical shear zone. There's a critical shear zone right here with this extra steel. So this puts us in the Now that might go all the way across. It might be 16 fives, might go all the way across. Right here, these 16 number fives and 10 number fours here. So I'm trying to triangulate that flower, the core sample. And it might be there, it might be in the 12 number fours, might be a little closer to that. If they hit the steel crosses each other. So we should look at this sample and see a 90-degree, let's go back to the sample, and see if we get a 90-degree rotation. Shit, I see there. So 90 would be down here. I can't see it. Hit the steel. Steel would have crossed it. Now I'll get a 90 on the other one, right? So I get a 90 on, let me zoom out a little bit. So I get a 90 on the other one, over here on maybe the parking garage. It looks like steel was in there, that little hole. I saw 2 pieces of steel in one of the samples. So let's go find it. Let's hunt that extra piece of steel. That's what the core sample looks like. Real nice, smooth holes. There's our steel. It's not quite 90. It looks more parallel than anything. 2 layers going in the same direction, just a little bit of rotation on it. Nothing to cry right home to mama about. That's nice and tight. So this steel it's a lot of friction there. It broke apart. This steel is engaged, married, solid right there. But it took this part is what it engaged with. This part took a grinding, like teeth. Ah, that's disgusting, but it's like teeth grinding apart. And that's interesting, a smooth section there. But it just ground apart. You can see how nice the steel looks there. You see the profile of the rib there. And this just ground apart. It's just junk. That's a lot of deflection that took place. It deflected, this part's deflecting, rubbing and knocking this part off. Down here, there's like teeth rubbing against each other. This is quite disgusting, an amazing find, of course. I've been waiting to get us there. Now I got us there through through the BMAs. Yes, BMAs, not BMA. Nibbler. Anyway, let me scroll over to your left. Let's end the video with that. So now I got you there. I got you into the garage. Now I got to do models to get you in there, right? I got to do a bunch of models to get you inside. You have to accept the data as it is. You can go over this video multiple times to get it in your coconut. And then I'll do the grinding model thing for you here. Take care, guys. Oh, please, I know it's a long video, but please watch the commercials for me. I think it might help. Comment, of course. Tell me what your commercial is. And that's about it. I want to joke around with Amy. I expect Amy to have quite a few Amy questions. Again, a shout out to everybody who, and I love you guys. You know, you supported me by commenting, but really the people who send me money, that's really awesome. I'm almost there, you know, not almost. You know, the money's going towards a better computer, and we'll be more amped up for the next round. A friend of mine's already looked into it. He told me something about some 9, like a gamer computer basically to do the software to what I needed to do. But we're still going to not get away from cardboard models. But I need better software for this crap. All right, but I don't want to go away out of Mac. That's my problem. All right, take care because I got too much vested in the software over here. Goodbye, folks. Love you all. Have fun. Hope this was enlightening. We now have our proof positive. Oh, I can't resist enough to say. I can't resist. I say, please stop following those engineers that tell you they're forensic engineers, that they're professional engineers. Look, they do testing nowadays, as you guys don't know. You can test, you get your PE license. You go to exam schools to learn how to pass the test. It's like a driver's ed class. You know the test already, so when you go there, you already know the questions. Same thing here. If they tell you they ran calculations, that means they have no idea how the real world works. This is going to have its own behavior. There's no reason to run a calculation. We're talking about real life here. This thing lasted 40 years. The problem was the car loading. Shouldn't have been out there. It was at 40 pounds per square foot. That sort of eliminates cars to me when you talk about curb pressure I talked about with you guys. All right. So love you all. Hang in there. Do what's bad. And if you're going to, like I always tell people, if you're going to be bad, be the best bad you can be. Be the best bad you can be. Be the best at it.